So if I am looking at my graph for this one, this is a square root function. We know that square root functions are going to end at an endpoint there. So our domain for this, we are looking at our possible x values. This would continue on this direction forever. So looking at this one, oh, and what would I have for my possible domain here, my x values? Negative infinity up to 0. Should I use a parentheses or a bracket here? Bracket. I include that point because we know square root functions are going to end at that point, and that point will be included. Okay. Questions on domain? All right, when we look at a range, it's the only time we look at the y values. So when we're looking at this, we're asking ourselves, what is the very lowest y value I will have? What is the very highest? So, Lydia, what would we have for our lowest number for our range? Negative 3. Very good. Should I use a bracket or a parentheses there? Bracket, because we have an endpoint that includes that. And what's the highest number I'm ever going to have? It does. It goes to positive infinity. It looks like, it's not very steep right there, but it just keeps going up forever, so it would be positive infinity. Okay? The next thing we need to do is look for positive and negative. I'm going to look at the negative part first just because it's easier to highlight on my graph here. So I have this section that I want to talk about. I need to know where this crosses right here, where that x-intercept is. Now, there is a way I can figure out exactly where it crosses, and I think I remember this graph is like very misleading here, even though I graphed it on Desmos, I thought it would be correct. So, at an x-intercept, what is my y-coordinate? Like, I know that it's 0, right? So, if I need to know the value, but I don't have, Desmos where I can actually graph it, because a lot of these, I may give you the picture of the graph, but it's just going to be a picture of the graph like you see here. It is not going to be interactive Desmos where you can click on it and get the exact point. So if I did, I could still do that because you could plug in 0 for your y-coordinate and just solve that equation, right? See where this equals 0. So if I add that 3, over here, 3 would equal the square root of negative x. What do I do to get rid of that square root? Square. So 9 equals negative x. Divide off that negative 1. Negative 9 equals x. I think this graph is very misleading because it does not look like it is at 9. But it should be. And I don't know if I typed something in wrong whenever I graphed it or what happened there. I may have typed something in wrong whenever I graphed it, even though it graphed this so beautifully, like the endpoint's perfect where it's supposed to be, so I'm not exactly sure, like that point's right, that point's right. I don't know about that. I'll try to make sure graphs do not look misleading on the test. So we are from negative 9 is that x-coordinate right there, up to, what do I put here? 0, not negative 3. Negative 3 would be looking at which axis? The y. Oh, I'm sorry. Yes, thank you. Yeah, I did negative first. Negative 9 to 0. Negative 9 I used a parentheses because at 0 it's neither positive nor negative. But right here at this endpoint, do we include the 0? Is that negative? Is it below the x-axis? It is, so we do include the 0. The reason we do not use the bracket for -9 is because at that point, we're on the x-axis. We are crossing that x-axis. Our y-coordinate is 0. 0 is not positive or negative. So because it's where you hit that x-axis, it's neither one. So use a parentheses there. So wherever your x-intercept is, whether you're doing positive or negative, you will not include that point. But for square roots, you include this endpoint over here because it is actually positive or negative. Now, positive would be over here in this direction. Right? This one can be a little bit confusing because it's in the negative direction that the graph is positive. Right? Positive means it's above the x-axis. So we would say from negative infinity up to -9, the graph would be positive. We would use parentheses for both there. Same reason here that we're using the parentheses right here with this -9, because it is on the x-axis, which is neither positive nor negative. Okay, square roots, a lot like logs and exponentials, are either always increasing or always decreasing. Which one is this? Is decreasing. So decreasing, we're just going to take whatever the domain was, we're going to put it down here for decreasing. So negative infinity to 0. And we would have none for increasing. Okay, questions here? All right, let's look at this one. This is a strange function. It's rational, but it's got that square there in the bottom. So if I were going to do domain for this one, I only have one issue, and that is right here. I've got this vertical asymptote. Right? So everywhere else this function is defined. So my domain would be negative infinity to 2. I would use a parentheses because I do not want to include 2. And then 2 to infinity. Okay, range for this one, Macy, what's the lowest I go on the y-axis? Very good. We will not include that because it is a horizontal asymptote. You don't ever actually touch 2, even though it will look like it actually does. And then, what's the highest this goes? Positive infinity. Very good. Positive and negative, I need to know what these points right here are. And it can be done. But for sake of time, let's just estimate on these. I will, on a simple one, like the last one that we did right here, I may expect you to know how to find that value, even if it's not clearly stated on the graph. For one like this, it is possible. You could say 0 equals this. You could solve it. But I do not want to spend the time right now to go over that, so I'm going to say that we're just going to estimate for this. If it's one where I would expect you to estimate on a quiz or a test, either it'll be multiple choice and there'll only be one answer that falls in that range, so you'll just kind of know, or I'll label those points for you there so you'll see. So let's estimate this at about 2.8, 0, and then this one over here at about 1.2, 0. We're estimating. If I actually gave this to you, I'd either label it or it'd be multiple choice where there was only, like I wouldn't put one of them that's 1.2 and another that's 1.5. I'd only have one between 1 and 2 there. So if we were looking for where this graph is positive, it's positive in all of this section right here, which is really from like 1.2 to 2.8, except is it positive at 2? No, because we have vertical asymptote. You've got nothing at 2, right? So we cannot include 2. So we would say 1.2 to 2 and 2 to 2.8. I'm using parentheses for everything there because at 1.2 and 2.8, I'm not positive or negative there because it equals 0. You are going to be negative everywhere else, so that is here and here. So if we're looking at where that's at, this goes on forever in this direction. Your negative infinity is over here. And that goes up to the 1.2. And then from that 2.8, this will go over to positive infinity on that x-axis there. And this is actually one of the first functions we've really looked at that's not always increasing or always decreasing. This one increases until you get to the vertical asymptote, then it decreases. So we would say that we are increasing from negative infinity to 2 and decreasing from 2 to infinity. Okay. Questions? Let's do this last one. Okay, so we don't even know what the function is for this one, but we have, I have not labeled all the points that we need here. Let's add some labels here. This one, I think, crosses at grid lines, so that would be, I think this is counting by 2s. Pretty sure it's counting by 2. So this point right here would be 4, 0. This point right here would be 3, 0. It's probably why I didn't label them, because they were be negative 2, 0. On my original, they were perfect grid lines. And negative 3, 0. Who thinks in a domain for this one? It is not negative 3 to 4. Because this graph, it keeps on going in this direction. And these are not vertical asymptotes here. It is negative infinity to positive infinity. So, the graph is pretty steep, but whenever you see something like this that's got like curves like this, unless they have put it in a dotted line to let you know, this is probably going to be all real numbers, negative infinity to infinity. What's our range? What's the very lowest y value that we could have here? Okay, y coordinate right here, which is negative 2.25. That's the lowest we see this graph ever go. What's the highest, Luke? Infinity. Oh, very good question. Is it a parentheses or a bracket? It actually hits that point, right? So I should have put a bracket for that positive and negative. Let's do, I'm going to do negative first because it's just like these small sections. I think it's a little bit easier. All right, so remember you're doing x coordinates. So we're negative from right here. X coordinate right here is -3 over to -2. So -3 to -2. And then again here from 3 to 4. So you will basically be positive everywhere else. So negative infinity up till you get to -3. And then you're negative here to -2. -2 over to 3. And then from 3 to 4, the graph is negative. And then 4 to infinity. Okay, questions there? Okay, increasing, decreasing switches several times on this, right? So we are decreasing till we get to here, then it increases, then we decrease again. So remember we're doing x coordinates for this. So if we're thinking about x coordinates, we're decreasing from negative infinity up until we get to this minimum point right here, which is -2.514. And there is some debate on whether or not to use parentheses or brackets at the maximum or minimums here. This is one that in calculus, whenever we do this, basically AP exam will just accept either one. Some argue that you are decreasing at that point because it is less than the point that was before it. Others would say that you're switching from increasing to decreasing, so you're doing neither one there. I generally just always use parentheses. My calculus teacher taught me that maximum minimums are where you switch so you don't. So I usually just do parentheses. I will not give you a question where using parentheses or not messes you up on that. I'll accept either one. So I also decrease from x coordinate right here is 0.5 up to the x coordinate here is 3.514. My general philosophy is that that point right there is where you're switching. You were going up, then you're going down. So you're like neither one. There is some debate on that though. So I will take either one really on these. So the only thing you cannot use a bracket with here is you cannot use it with the infinities. We can never use brackets with infinities. But if you use brackets for all of these instead, I would still take it. But it's more likely that I have used parentheses whenever it's multiple choice, which these usually will be. All right, we increase here and here. So that would be x coordinate right here is -2.514 up to the x coordinate here, which is 0.5. And then x coordinate here is 3.514, and then to infinity. There. questions? All right, I have got a quizzes that we're going to do to practice this a little bit. So today we're going to do some more practice with composition of functions. I just wanted you to see a few different types of composition of functions that you might see. So these first couple are from a table. So if I'm asked to find f of g of 4, what is the x value where we are looking at? 4, right? Our x equals 4. So if I'm looking at the table, I'm going to go right here to where x equals 4. Which function am I looking at? G. So those would cross right here. G of 4 would be 1. But that's just the inside part, right? So G of 4 equals 1. So now I have f of 1. So f of 1, I'm looking where my x equals 1. We are looking at the f function. So that would be this cell right here. So this would equal 1. Right, it's just f of g of 4 equals 1. So you wouldn't say x equals 1 there. So just 1 would be your answer. All right, try the second one there on your own. All right. Okay, let's see. Mallory, what do we get when we do f of 3?
I got 1.
That is correct. So that means that we're now doing g of 1. And what is g of 1? Okay, so g of 1, our x value is 1. We're looking at the g function. Those two rows meet right here. So we will get 4 for that. Yeah, you got to be very careful when you have a big table like this. You got to look where what your x value is right here. All right, questions on that first part? All right, let's look at one like example 3. Okay, so I'm given f of x equals x squared minus 4x. I'm asked to find f of t plus 2. This means I'm taking t plus 2, I'm plugging it in for my x's. So f of t plus 2 would be t plus 2 squared minus 4 times t plus 2. It is, yeah. It's a different way of asking, but it's basically the same here. So now, technically, this is what this equals, but probably you're going to see answers have been simplified. So t plus 2 squared, let's try our shortcut. We're going to square the first. So that's t squared. We need to multiply these two together and double to get our middle term. So we got 2 times t is 2t. If we double that, we get 4t. And then we square the last. 2 squared is 4. And then I will need to distribute that negative 4, so I'll get minus 4t minus 8. If you need to, if you're not getting this part right here, if you must, write it out over to the side. I would rather you be slow than incorrect. So write it out if you need to. Distribute there, but it is best if you can do that part in your head. And then combine like terms, so you get t squared. The positive 4t and negative 4t actually cancel each other out, so they are gone here, and you'll just get minus 4. So you'll get t squared minus 4. Okay? So a problem like this where you're asked to plug in something with a variable, you'll still have a variable in your answer most of the time, unless everything cancels for some reason.
Is it possible for a question like that to be
It would have to have a denominator somewhere for that to be the case, where you're getting like a 0 in the denominator or something. So not on this particular one, but it could happen maybe. It is possible that like whatever you plug in cancels out and you just get 0 or something as your, or 7 as your answer, but most of the time it's going to have variable. All right. Okay. We've got 2x minus 7 and x plus 4 squared. It asks us for f of g of x and g of f of x. And did you guys see this notation?
Yes.
Did you see it like this?
Yeah.
Okay. All right. So I was making sure that both of those have been used because I did not go back and rewatch that video. I recorded it last year. So, all right. So you may see either one of these. G here is being plugged into F. So F of G of X would be 2 times x plus 4 squared minus 7.
You do the 2 times x plus 4 first.
You must, so if we're doing order of operations, we have to do exponents before we multiply. So you cannot distribute the 2 yet. You have to square x plus 4 squared. You can write it twice if you would like. Over to the side, x plus 4 times x plus 4. Distribute there. Shortcut, square. Double, so x times 4 is 4x. If we double it, we get 8. So we get 8x. And then square the last. We should get 16 right there. Don't forget your minus 7. You must expand that before you distribute. So 2x squared plus 16x plus 32 minus 7. So we get 2x squared plus 16x plus 25. Okay. To do the second one, we're doing the opposite. We're taking 2x minus 7 and plugging it in for our x. So that will look like this. We'll have 2x minus 7 plus 4 squared. So for this one, you would combine that negative 7 and that 4 first. So you'll get 2x minus 3 squared. You do not, because these parentheses right here still have that plus after it. So the parentheses don't really do anything here. We like to include them every time we plug something in because sometimes it really matters. But because, so if you're like thinking about those parentheses, there's a 1 in front of it. You could distribute that 1 there. It would just be 2x minus 7 plus 4. So you will not do, if it was a 4 and there was not a plus sign there, if it was like this parentheses times 4, then you would distribute. But since it's got the plus, you do not distribute. And then so here we can use that shortcut or write it twice if you need to. 2x squared would be 4x squared. Multiply these two together, we get negative 6x. Double it, we get negative 12x. And then square the last. 3 squared is 9. Okay, here. Okay. This, whenever we're taking a function and plugging it into another function, is called composition of functions. Now, there is something else that you are going to be expected to know how to do, which is just basic operations with functions. And so, I have 3 functions here. This is absolute value bars. They don't look very absolute value bar-y because I just typed a nail, but those are absolute value bars. So, whenever I see something like f plus g of x, we are not taking one and plugging it into the other. What this means is I'm just doing f of x plus g of x. Okay? So, f of x is 9 minus x, and g of x is x minus 1 squared plus 3. So here, I would need to square the x minus 1. So I got 9 minus x plus, this is going to be x squared minus 2x plus 1. If we square, double square, plus 3. And then we would just combine our like terms. So we'd have x squared. We got a negative 3x. And then 9, 10, 13. Something like example 7 is asking us to find f of 3 minus h of 7. So you can just find f of 3, which is 9 minus 3, which gives us 6. You can find h of 7, which would be 7 plus 2. In the absolute value bars, you're going to get 9. So f of 3, right here, that's 6. And h of 7 is 9, so 6 minus 9 would give you negative 3. So you can just find those two parts separately and then do whatever operation you see. One of the most commonly missed problems is number 8. And that is because there is a very tiny difference here. Notice that dot right there is closed in. What does that mean? It is multiplication. It is not f of g of 4. It is f times g of 4. So that really means f of 4 times g of 4. So pay close attention. If it is the open circle, it's composition of functions. You're doing f of g of 4. You're plugging into g first, then you would plug it into f. If it's a closed, like colored in circle, it's multiplication. So it's asking you to do f of 4 times g of 4. So for this one, I can find f of 4 is 9 minus 4, which is 5. G of 4 would be 9 minus 1 squared plus 3. And so that would be 8 squared. Oh, I don't know. Let's put a 4 there. Back up. 4 minus 3 squared plus 3. So 3 squared plus 3. 9 plus 3, which is 12. So f of 4 was 5. G of 4 is 12. 5 times 12 would be 60. So 60. This is, when you see f times g and then the parentheses of 4, it means f of 4 times g of 4. I don't love this notation. I like it better just written like this, but you will see this sometimes. 4 minus 1 is 3. And last one we have here is h over f of 6. This means h of 6 divided by f of 6. Oops. So much like we've done on the other problems, we can just find h of 6, which for this one is just absolute value of 6 plus 2, which is going to give us 8. And f of 6, which is 9 minus 6, which is 3. So we would just have 8 over 3. That doesn't reduce, so 8/3 would be our answer. All right. For your assignments tonight, I need to show you, you guys, I don't think you have done a worksheet like these before. I know you haven't done it in class. I love these worksheets. I can give you the answers without really giving you the answers. Alright, let me make sure everybody knows how to do these worksheets. So, these are circuit worksheets. Which hopefully it's going to bring up here. So I have an extra. Anybody not get one? Okay, so I love these worksheets. Some of these are going to be super duper simple. You're going to start with this one right here. And it just asks you to find f of negative 3. So f of negative 3 would just be 3 times negative 3 squared plus 4 times negative 3 minus 7. That would be 3 times 9. Make sure you do your exponents first. Negative 12 minus 7. So 27 minus 12 minus 7 is going to be, see, 27 minus 12 is 15 minus 7, 8. Okay, so we get 8 as our answer. So what you will do is you will scroll through the worksheet, and there should be one, there it is, right there, that says the answer is 8. Okay, so we're going to put number 2 here because this is the second question that we are doing. Then we will work out and find g of negative 3. So we'll plug that in here. We'll get the answer. Let's say the answer is negative 56. I don't think it is, but if it was, then we would put, if it was negative 56, we'd put number 3 right here. We'd work out that problem. We'll find that answer. We'll scroll through the worksheet wherever that answer is, maybe 15. Then we would put 4 right here. So every problem you should have, it's the first problem you did, second, third, fourth. You're not going to be in order. If you're going 1, 2, 3. Yeah, and so if you miss one, the answer will not be there for those answer choices, right? And if you do it correctly, it takes you back to answer number 1. So the answer to the last question should be t squared plus 6t. Okay? So this will be your homework assignment for tonight.